Hello everyone. So I welcome you again in this lecture, and today we are going to talk about heap sort. Heap sort is one of the interesting sorting technique that runs on n log n time. Now heap sort is based on the concept of heap, so I am assuming that you are already familiar with the concept of heap. You understand how to build a heap, you know how to apply heapify, you know how to do the extract, heap max. Already we have covered these algorithms in the previous lecture. So all these algorithms we are going to use it again here, and we will see that how the heap sort technique will work and sort the given sequence. We will also analyze its running time, and we will apply this algorithm on one numerical to have a feel that how it actually works. So let's start. Okay, let's talk about the heap sort strategy before we actually move to the formal algorithm. So what is required here? We are provided with one sequence of elements and we are interested to sort the sequence. So the very first thing is you need to arrange the given elements in a heap. So when I say heap, here we are taking a maximum heap. Heap can be of two types, a minimum heap or a maximum heap. In our case, in our example, we are working with a maximum heap, but the same thing can also be applied to a minimum heap. Now when you convert the given sequence in a heap, then with this heap you are able to get your sorted sequence. The strategy says by using the property of heap, in the max heap, what is observed, the node value will always be more than the child value. As a result, the root contains the maximum value. So out of given all the elements, we are very sure that what is the maximum value that exists at the root. So what we will do, we will take this value, root value, and then we will be keeping this root value at the last index of the array. And the same strategy we will keep on applying with every other nodes of the given heap. So we keep on applying this with the other elements by again reheapifying again and again, and when we do all the iterations and when we stop, you will find that your list is sorted. We will do this step by step by applying the entire steps on one algorithm. So how does it actually work? So in order to apply the heap sort, we need to familiar with some operations, like you must be knowing what is max heapify, what is build max heap, what is heap extract max. So all these things will be, all these algorithms we are going to use in this heap sort. So if you have not gone through this algorithm, I would suggest you to first go through this algorithm that we have already discussed in the previous lecture, and then you come back to this heap sort. Keep in mind that ascending and descending sequence will always be a minimum and maximum heap respectively. So if any ascending sequence is given to you and if you convert a binary tree out of that, then you will be going to get a minimum heap. Similarly, the descending order will give you the maximum heap. Okay, so let's move next. Let's have a look at how the heap sort works. This is a graphical representation to have a feel that how the heap sort is actually working. So the very first step is you need to build heap. So a sequence is given to us. We will apply the build heap method, and with the build heap method we are able to convert the sequence into the heap. So this is now converted to the heap. Now in here you can see that every node is having more value than its child, and as a whole the root is containing the maximum value. So we are very sure that this value is the maximum value. So we will take this value and we will write in our array. So let's say if you are having an, so here you can see 1 2 3 4 5 6 7 8 9 10. So if you make an array and if you write the value, first value 1 2 3 4 5 6 7 8 9 10. Now this is your given array and this is also a heap. Now the very first step is, because we are very sure that this is the maximum value, we are going to uh, remove this value, and we are in place of this value we are writing the last value here. So we will bring the last leaf to the root and we will write 50 here. The next time when we work with the heap, our heap will be reduced by size 1. That means now we have to work with only this much array, because this already we have find the correct position, that is 50. Now once you keep 6 here, now this is no more a heap when you write 6 here. And you can also observe here that now this size is reduced. Now this leaf is missing here because we have reduced the size. Now when you write the 6 here, this is no more a heap. Then we have to apply the heapify method. Heapify method we already discussed. This method ensure that the tree maintains the order property. Order property means the value at any node must be more than equals to the value at the child node. So here we will apply the heapify at the first node. Then what will happen? It will compare with the child. We will go through the entire heapify method. So I am just doing it quickly. So it will compare with the child. So it will find that this child is having a more value. So it will be going to swap here. This becomes 30 and this becomes 6. And again it will again call heapify method and it will check it again with its child. Heapify method is a recursive method which keep on calling until you reach to the leaf, or you reach to the node which is already maintaining the key value which is more than the child key value. So when you are swapping with this node, then again the heapify method is being called and again it will compare. So it will find that it has to be swapped again. So 18 will go here and 6 will come here. So these are all the intermediate steps that we have actually discussed here. So at last what you will observe this tree you are getting, that 30 is at the root, 18 here, 6 here, and this leaf is removed. Now this step you have to keep on doing. So we have applied this one time, and this step we have to apply it for n minus 1 number of times. N minus 1 number of time means n we are assuming is a number of nodes. So n minus 1 time we have to do this step again and again. So again in the next time we will pick this value 30 and we will write here, and then we will reduce the size to array by 1. So we keep on uh, replacing the first value with the last value and decreasing the size of the heap, and we keep on doing for n minus 1 time, and when you stop you will find that your resultant is a sorted. So let's go with the formal algorithm of heap sort and we'll apply this to some example. So this is an algorithm of heap sort. So here we have to pass an array which you are interested to sort. So the very first step is you have to apply the build max heap. So this sequence which is given to us, it may not be a heap initially. So we will do the build max heap algorithm and convert that sequence into a heap. Then for I equals to length a down to 2. So length a means is the number of element in the heap. So the size of the heap. So from this down to 1, that means you have to do n minus 1 time. So if the size is 7, then you are doing from 7 to 2. Okay, that means you are doing n minus 1 time. So n minus 1 time you are doing this. What actually you are doing? You are exchanging the first element with the last element. Okay, so I is actually referring to the length of a means the last element. So you are exchanging this and decreasing the size by 1. So every time, as we have discussed, when you are swapping the last element with the root element, then you decrease the size of the heap by 1. And then you have to apply the heapify operation at the root node, because when you swap the value from the root node, so if this is a scenario, this is the last leaf, and when you swap this value with the root node, then this is no more a heap, so you have to apply the heapify at this node. So this is the heap sort algorithm. Now we will also apply the algorithm in some example, but before moving to the example, let us talk about the running time, that how much time it will take to give our solution. So the very first step is we are doing the build max heap. and the cost of build max heap is big O of n. Already we have discussed. The running time of build max heap operation is big O of n. Now we are doing this n minus 1 time we are doing something, and what actually we are doing, we have to do this n minus 1 time. Every time we have to perform these operations, and what exactly we are having, we are exchanging the last value with the first value, which is a constant operation. You are decreasing the size, which is again is a constant effort. Max simplify is something that requires some effort, uh, that cost log n. So this log n effort you have to do n minus 1 times, because this loop is actually working for n minus 1 time. So the effort for this entire step is n minus 1 into log n, which is nothing but big O of n log n. So the total effort of the heap sort can be find out by adding the both the efforts. So the total effort, or you can say the total running time, is equals to big O of n plus big O of n log n, which is nothing but big O of n log n. So here you can see that the running time of heap sort is also equal to the merge sort algorithm. So just to summarize, running time of build heap is big O of n, max heap is n log n, and total time is big O of n log n. Now we will apply this to some numerical